Okay, so get this right. You've got the red planet, Mars.
Mm-hmm.
Everyone knows Mars.
Right.
Dusty, rusty red, that whole thing.
Yeah.
But here's where it gets wild. Mars has not one, but TWO moons.
Huh.
Tiny, oddly shaped moons
Yeah.
called Phobos and Deimos.
Okay.
We're talking like potato-shaped moons.
Wow.
And their origins.
Yeah.
A total cosmic mystery.
Interesting.
Are they captured asteroids or like the remnants of some ancient Martian catastrophe?
Mm-hmm.
Today's deep dive takes us right into the heart of that mystery.
Okay.
And I've got an expert guide right here who can, hopefully, shed some light on these celestial oddities.
I'll do my best.
Welcome to Cosmos in a Pod, Space and Astronomy series.
Huh?
So first things first, can you give us the lowdown on Phobos and Deimos? How big are these potatoes anyway? And what makes them so different from our own moon?
Well, you're not wrong about the potato comparison.
Okay.
They're oddly shaped.
Yeah.
In terms of size, Phobos, the larger of the two, is only about 22 kilometers in diameter. Deimos is even smaller. It's at a mere 12 kilometers.
Wow.
That's incredibly tiny compared to our moon,
Right.
which is over 3,400 kilometers across.
Yeah.
So yeah, these are definitely the runts of the cosmic litter.
Wow. That really puts things into perspective. I mean, 22 kilometers, that's like barely a long bike ride.
Mm.
Okay, so we've got these two little guys zipping around Mars. What else makes them stand out in the solar system's moon lineup?
Their orbits are particularly fascinating,
Okay.
especially Phobos.
Yeah.
It orbits incredibly close to Mars, a mere 6,000 kilometers above the surface.
Wow.
Making it the closest moon to any planet we know of.
6,000 kilometers.
Yeah.
That sounds a little too close for comfort. Like it's practically skimming the Martian atmosphere. Is
Yeah.
it in any danger?
You're right to be concerned. Because it's so close, Phobos is experiencing some serious gravitational tug-of-war from Mars.
Oh.
Those tidal forces are pulling it closer and closer.
Oh, no.
In fact, it's predicted to eventually collide with Mars
What?
in about 50 million years.
50 million years. Well, that gives us some time to plan a going-away party. But seriously, what will happen when it collides? Will it just go splat on the surface?
Well, there are a couple of possibilities. It could indeed crash directly into Mars, creating a massive impact crater.
Oh, wow.
But there's also a chance that Mars's gravity will rip Phobos apart before it even reaches the surface.
Oh.
In that scenario, the debris could spread out and form a temporary ring around the planet.
Wait, a ring around Mars. Now, that would be a view. Okay, so Phobos has got this dramatic destiny ahead of it. What about Deimos? The quieter, more distant sibling. What's its story?
Deimos is a bit of an enigma.
Okay.
It orbits much farther out at around 23,500 kilometers from Mars.
Oh, okay.
And unlike Phobos, it's slowly drifting away from the planet.
Really?
Its surface is also much smoother compared to Phobos's heavily cratered landscape.
So one's spiraling inward towards a fiery demise and the other is just drifting off into the cosmic distance.
Yeah.
They're like the planetary equivalent of a dysfunctional family.
That's one way to put it. And that brings us to the heart of the mystery surrounding Phobos and Deimos. Where did they come from in the first place?
Okay, let's get to the bottom of this. Hit me with the theories.
There are two main contenders. The first is the captured asteroid theory,
Okay.
which suggests that Phobos and Deimos were once asteroids minding their own business in the asteroid belt until Mars' gravity snagged them.
So Mars was feeling a little lonely and just decided to adopt a couple of asteroids as moons? Seems a bit rude, but okay. But doesn't that seem a little too random? Wouldn't captured asteroids have more erratic orbits?
You've hit on one of the key challenges to this theory. Phobos and Deimos have surprisingly neat, almost circular orbits that align with Mars' equator.
Oh.
That's quite unusual for captured objects, which tend to have more elliptical and chaotic paths.
Okay, so maybe Mars didn't just go around asteroid napping. What about the other theory? What's the alternative explanation for these odd little moons?
The other possibility is the impact debris theory. This proposes that a massive object, perhaps a protoplanet or a large asteroid, slammed into Mars billions of years ago.
Right.
The impact would have been powerful enough to launch a huge amount of debris into space.
Like a cosmic car crash, Martian style.
Yeah.
Okay, I'm picturing a giant explosion, debris flying everywhere.
Yeah,
And some of that debris clumped together to form Phobos and Deimos.
exactly. Over time, this debris could have coalesced under its own gravity, forming the moons we see today.
All right, so we've got these two possibilities. And it's like choosing between a cosmic adoption story and a dramatic space collision. Both seem pretty wild to me.
Yeah,
But which theory has more evidence to back it up?
that's the million-dollar question, and honestly, it's still hotly debated in the scientific community.
Right.
There's evidence supporting both sides, which makes this whole thing even more intriguing.
All right, spill the beans. What are the key pieces of evidence for each theory? What makes this debate so complex?
Well, let's start with the captured asteroid theory. One of the biggest pieces of evidence in its favor is the composition of Phobos and Deimos.
Okay.
They seem to be made of a type of material called carbonaceous chondrites,
Right.
which is very similar to what we find in certain types of asteroids.
So their insides are basically saying, we're space rocks.
Right.
But what about their orbits? You said those neat orbits were a problem for the captured asteroid theory.
Right, and that's where things get tricky. To account for those orbits, some scientists have proposed a fascinating idea. What if Mars once had a ring system,
Okay.
much like Saturn's rings,
Right.
but made of rocky debris instead of ice?
Hold on, Mars with rings. That's a mind-blowing image. But how would that explain how these supposed asteroids got captured into such nice circular orbits?
Think of it this way. Imagine those asteroids wandering through space and encountering this ring of debris around Mars. As they interacted with the ring particles, they would have gradually slowed down, losing energy, and eventually spiraling into those stable orbits we see today.
So the ring acted like a cosmic brake pad,
Yeah.
taming those wild asteroids.
Yes.
That's pretty ingenious.
Yeah.
But is there any actual evidence that Mars ever had rings?
It's still a hypothesis, but there is some indirect evidence.
Okay.
For example, some scientists believe that the giant impact that might have formed Phobos and Deimos could have also created a temporary ring system.
Oh, wow.
The debris from that impact could have lingered around Mars for millions of years before eventually coalescing into moons or falling back to the surface.
Okay, so that's an interesting twist on the captured asteroid theory. That's like
Yeah.
a two-for-one deal.
Yeah.
A giant impact a temporary ring system.
Right.
But what about the impact debris theory? What evidence supports that side of the story?
One of the strongest pieces of evidence for the impact debris theory is, well, the impact itself.
Okay.
There's a massive impact basin on Mars called the Borealis Basin. It's one of the largest impact craters in the entire solar system.
So we've got a crime scene.
Mm.
And the impact debris theory is basically saying that Phobos and Deimos are the remnants of that cosmic hit and run.
Exactly. The impact that created the Borealis Basin would have been catastrophic, ejecting an immense amount of Martian material into space.
Right.
And some scientists believe that a portion of that debris could have coalesced to form Phobos and Deimos.
Okay, so we've got the potential for a temporary Martian ring system, A&D, a giant impact crater.
Mm-hmm.
This is getting more and more dramatic.
Mm.
But I'm still curious about the composition of these moons.
Yeah.
You said they're similar to carbonaceous chondrites, which are asteroids, right?
Right.
But if they formed from debris blasted off Mars, shouldn't they be made of Martian stuff?
That's a great point, and it's one of the ongoing puzzles.
Yeah.
However, recent research suggests that the composition of Martian rocks can vary significantly depending on where you look.
Okay.
There's a region on Mars called the Northern Lowlands, which is thought to be composed of very ancient crustal material. And some studies suggest that this material might have a composition that's closer to what we see in Phobos and Deimos.
So if the impact happened in that region, it could have blasted off material that was more asteroid-like in composition.
Exactly.
Okay.
So it's possible that even though they formed from Martian debris, they ended up with a composition that resembles asteroids. It's a complex puzzle, and scientists are still piecing together all the clues.
Okay, so we've got these two theories, each with its own set of strengths and weaknesses.
Mm-hmm.
It's a cosmic detective story, and the evidence is leading us in different directions. But there's one thing we haven't talked much about yet, the MMX mission. What role could this mission play in solving the mystery of Phobos and Deimos' origins?
The MMX mission could be a game changer. Remember, it aims to land on Phobos, collect samples, and bring them back to Earth for detailed analysis.
It's like a cosmic grab and go. But how will these samples help us figure out where these moons came from?
By studying the composition, age, and structure of the samples, scientists will gain a much deeper understanding of Phobos' makeup.
So it's like having a piece of the puzzle delivered right to our doorstep.
Pretty nicely.
Gotcha.
And with that piece, we might finally be able to solve the puzzle of Phobos and Deimos' origins. The data from the MMX mission could provide definitive evidence for one theory or the other,
Right.
or perhaps even lead to a completely new understanding.
I can't wait to hear what they discover. This mission has the potential to rewrite the textbooks on Martian moons. But speaking of Phobos, there's another intriguing aspect to this moon that I want to explore.
Mm-hmm.
We've talked about its eventual demise.
Right.
But before it meets its fiery end, could Phobos actually play a crucial role in our future exploration of Mars?
Ah, you're talking about the idea of using Phobos as a base camp for Martian exploration.
Exactly. It's like a stepping stone to the red planet.
Tell me more. What makes Phobos such a valuable asset in our Martian ambitions?
Well, think about it. Phobos is incredibly close to Mars.
It's like having a front row seat to all the Martian action.
So we could have telescopes and instruments on Phobos, giving us an unparalleled view of the Martian surface.
Absolutely.
Cool.
We could study the Martian atmosphere, monitor weather patterns, and even scout out potential landing sites for future missions. And because Phobos is tidally locked to Mars, always showing the same face to the planet, we could have continuous monitoring of specific regions of interest.
Okay, I'm starting to see the appeal.
Yeah.
It's like having a Martian observatory, but way closer to the action.
Right.
But what about actually getting to and from Mars? Wouldn't that still be a major challenge?
That's where Phobos's low gravity comes into play. Remember, its gravitational pull is much weaker than Earth's or even Mars.
Right, we talked about that earlier. It's like a cosmic featherweight.
Yeah.
But how does that make things easier for space travel?
Well, it takes significantly less energy to launch a spacecraft from Phobos compared to Earth or Mars.
So we could send robots, supplies, and maybe even humans to the Martian surface much more efficiently.
Exactly. And landing on Phobos itself would be much safer and simpler than landing on Mars. We wouldn't have to worry as much about atmospheric drag or the complexities of landing on a planet with a substantial atmosphere.
Wow, I never thought about it that way. It completely changes my perspective on Phobos. It's not just a doomed moon. It's a potential gateway to the red planet.
It is. And by establishing a base on Phobos, we could learn a lot about the moon itself,
Yeah.
especially its internal structure.
Yep.
We could conduct seismic surveys, drill into the surface, and even set up a network of sensors to monitor its environment.
So Phobos is a stepping stone to Mars ND, a scientific goldmine in its own right. But what's the current status of this idea? Are there any concrete plans to build a base on Phobos anytime soon?
Well, it's still in the early stages of development, but many space agencies and private companies are seriously considering it.
Okay.
Some have even proposed using 3D printing technology to construct habitats and other structures on Phobos, utilizing materials found on the moon itself.
3D printed habitats on a Martian moon. Now that's some next level space exploration.
It is, and it highlights how our understanding of Phobos and its potential has evolved over time. It's no longer just a curious little moon. It's a potential key to unlocking the secrets of Mars and pushing the boundaries of human exploration.
I'm totally captivated by this vision of Phobos as a Martian outpost.
Mhm.
But before we get ahead of ourselves, let's go back to basics for a moment. We've talked about the external features of these moons, their orbits, their potential origins. But what about their internal structures?
Yeah.
What's going on beneath those cratered surfaces? Are they solid chunks of rock? Or is there something more unexpected lurking inside?
That's a great question, and one that scientists are still grappling with. One of the biggest clues we have is their surprisingly low density.
Right, you mentioned that earlier. They're much less dense than typical rock.
Yeah.
Like they're not as packed as you'd expect.
Exactly. And that low density has led some scientists to propose that Phobos and Deimos might not be solid objects at all, but rather rubble piles.
Rubble piles.
Yeah.
So not a single solid piece of rock,
Right.
but more like a bunch of smaller rocks and debris loosely held together by gravity.
Precisely. Imagine a giant cosmic Jenga tower, but instead of wooden blocks, it's made of rocks and boulders of various sizes with lots of empty spaces in between.
Wow, that's a wild thought. Cosmic Jenga in space. But how could something like that even form?
Well, if Phobos and Deimos are captured asteroids, as some scientists believe, they might have formed from the gradual accumulation of smaller objects in the early solar system. Over time, these objects would have collided and stuck together, forming a loosely bound rubble pile.
Okay, so it's like a cosmic snowball effect.
Yeah.
But with rocks instead of snow. But what if they formed from the impact debris like we talked about earlier? Could a giant impact create a rubble pile moon?
Absolutely. If the impact that formed Phobos and Deimos was powerful enough, it could have shattered the original Martian material into countless fragments. Those fragments could have then coalesced under their own gravity, forming a moon that's more like a loosely bound collection of debris than a solid object.
So these little moons could be like giant cosmic jigsaw puzzles
Yeah.
made up of pieces of ancient Mars.
Exactly, and that makes studying their internal structures even more fascinating. By understanding how these rubble piles are put together, we could learn a lot about the composition of the early Martian crust,
Oh, wow.
and even potentially find clues to the conditions on Mars billions of years ago.
Wow. It's like having a window into the ancient history of Mars.
Uh-huh.
But how can we actually figure out what's going on inside these moons? Can we just send a giant X-ray machine into space?
I wish it were that simple. Unfortunately, we can't just see through these moons,
Right.
but there are other ways to probe their internal structures.
Okay, I'm all ears. What tools do cosmic detectives use to study the insides of moons?
One powerful tool is gravity. By carefully tracking the motion of spacecraft orbiting Phobos and Deimos, scientists can map out their gravitational fields in great detail.
So how does gravity tell us what's going on inside?
Well, the strength and shape of a moon's gravitational field depends on how its mass is distributed.
Okay.
If a moon is perfectly uniform and solid, its gravity field will be smooth and symmetrical.
Okay, makes sense. So if the gravity field is kind of lumpy or irregular, it means the mass isn't evenly distributed.
Exactly.
Okay.
And those variations can tell us a lot about the internal structure of the moon. For example, if we detect a region with slightly weaker gravity, it might indicate a large void or cavity inside the moon.
So it's like using gravity as a cosmic stethoscope, listening for clues about the moon's internal health.
That's a great analogy. And another technique we can use is seismic waves.
Seismic waves.
Yeah,
Like the waves generated by earthquakes.
exactly.
But how can we study earthquakes on a moon that doesn't seem to have any tectonic activity?
Well, we can create our own seismic waves. Scientists have proposed sending spacecraft equipped with impactors to Phobos.
Oh, wait.
These impactors would be released and would collide with the surface,
Right.
generating seismic waves that would travel through the moon's interior.
It's like giving Phobos a gentle cosmic tap to see what kind of sound it makes.
Uh-huh.
And by studying how those seismic waves propagate, we could learn about the different layers and materials inside.
Exactly. It's similar to how geologists use seismic waves from earthquakes to study the Earth's interior. By analyzing the speed and direction of these waves, we can create a detailed picture of what lies beneath the surface.
Wow. It's like giving Phobos a cosmic ultrasound. And all this information could help us figure out if those moons are truly rubble piles or something else entirely.
Precisely. And not only that, but the information we gather about their internal structures could have implications for our understanding of their origins, their potential to harbor resources, and even their potential to hold clues to ancient life on Mars.
Okay, now you've really piqued my curiosity. How could the internal structure of these moons tell us about the possibility of life on Mars?
Remember we talked about the possibility that Phobos and Deimos contain fragments of ancient Mars blasted off during impacts?
Right, the little time capsule idea.
Well, if those fragments came from deep within the Martian crust or even the mantle, they might contain evidence of past life.
Okay.
Imagine if we find fossilized microbes or organic molecules trapped within the rocks of Phobos.
Whoa, that would be mind-blowing. Finding signs of Martian life on its own moon.
It's a long shot, but it's not impossible, and the MMX mission, with its goal of bringing back pristine samples from Phobos, could provide the answers.
I'm starting to see why this mission is such a big deal. It has the potential to unlock so many secrets, not just about Phobos and Deimos, but about Mars itself.
Exactly. And it highlights how even the smallest, seemingly insignificant objects in our solar system can hold the keys to unlocking some of the biggest mysteries of the universe.
Well, we've covered a lot of ground in this deep dive, from their potato-like shapes to their mysterious origins and their potential as stepping stones to Mars. But there's still one intriguing aspect of these moons that we haven't touched upon yet: their cultural significance. What role do they play in our collective imagination, in mythology, or even in science fiction?
That's a great question, and it's one that takes us beyond the realm of pure science and into the world of human storytelling and imagination. Phobos and Deimos, named after the Greek gods of fear and panic, respectively, have certainly captured the imaginations of writers, artists, and filmmakers for generations.
Just their names alone, Phobos and Deimos, sound pretty ominous. I can see why they'd be popular subjects for science fiction.
Exactly. Their evocative names and their close proximity to Mars, a planet that has always held a special fascination for humanity, have made them popular settings for sci-fi stories. They're often depicted as desolate outposts, mysterious alien worlds, or even gateways to other dimensions.
Have there been any notable depictions of Phobos and Deimos in pop culture that come to mind?
Oh, definitely. One classic example is the science fiction novel The Martian Chronicles by Ray Bradbury.
Okay.
In one of the stories, human colonists on Mars witness the destruction of Phobos, a terrifying event that foreshadows the eventual collapse of their own civilization.
Wow, that's pretty heavy. It's like
Yeah.
Phobos becomes a symbol of the fragility of human ambition in the face of the vast and often unforgiving cosmos.
Exactly. And it shows how Phobos and Deimos can serve as more than just physical objects in our stories. They can represent our fears, our hopes, and our enduring fascination with the unknown.
So even though they're tiny compared to our own moon, they hold a big place in our cultural landscape.
Absolutely. They remind us that even the smallest objects in the universe can spark our imaginations and inspire us to explore the boundaries of what's possible.
Well, it seems like we've reached the end of this leg of our journey.
Yeah.
We've peered into the hearts of these Martian moons, explored their mysteries, and even pondered their place in our collective imagination. It's been an incredible deep dive, and I feel like I've learned so much.
It has been a fascinating exploration, and it highlights how much we've learned about these once enigmatic objects, while also reminding us of how much there is still left to discover.
Before we wrap up this part of our deep dive, any parting thoughts for our listeners as we move on to the final part of our exploration?
I think one of the biggest takeaways here is that even in our own cosmic backyard, there are still so many mysteries waiting to be uncovered.
Yeah.
Phobos and Deimos, these little potato-shaped moons, have turned out to be far more complex and intriguing than I ever imagined.
They really are a testament to the power of scientific curiosity. Every new discovery opens up even more questions, pushing us to dig deeper and explore further. Well said. As we move on to the final part of our deep dive into the mysteries of Phobos and Deimos, what else can you tell us about these fascinating moons? What other secrets are they hiding?
Well, we've talked about their origins, their potential as stepping stones to Mars, even their presence in our collective imagination. But there's one more aspect of these moons that I find particularly intriguing: their potential to harbor clues to ancient life on Mars.
Wait, really? How could these little moons tell us about the possibility of life on Mars? I thought that was all about studying the Martian surface, drilling for fossils, and analyzing the soil.
You're right, those are all important avenues for investigating the potential for life on Mars. But remember, we discussed the possibility that Phobos and Deimos contain fragments of ancient Mars blasted off during impacts.
Right, the cosmic time capsules. So you're saying that if those fragments came from the right place on Mars, they might contain evidence of past life?
Exactly. Imagine if those impacts excavated material from deep within the Martian crust or even the mantle, where conditions might have been more favorable for life billions of years ago.
So we could potentially find fossilized microbes, organic molecules, or other signs of ancient Martian life trapped within the rocks of Phobos.
It's certainly a possibility, and one that makes the MMX mission even more exciting. If those samples contain evidence of past life, it would be a monumental discovery, not just for our understanding of Mars, but for our understanding of life in the universe as a whole.
It's incredible to think that these little moons, once thought to be just chunks of rock, could hold the key to answering one of humanity's biggest questions. Are we alone in the cosmos?
It really is a testament to the interconnectedness of everything in our solar system. These seemingly insignificant objects orbiting a distant planet could hold the answers to questions that have puzzled us for centuries.
Before we wrap up this final part of our deep dive, is there anything else about Phobos and Deimos that you'd like to share with our listeners? Any final thoughts or insights that you think they should keep in mind as they continue to explore the wonders of the universe?
I think the most important thing to remember is that exploration is a journey, not a destination. There's always something new to discover, something more to learn. Phobos and Deimos are just one small example of the incredible diversity and wonder that exists in our solar system and beyond.
Well said. And I hope our deep dive into these Martian moons has inspired our listeners to keep looking up, keep asking questions, and never stop exploring the vast and mysterious universe we call home.
Me too! And who knows what incredible discoveries await us just around the cosmic corner.
Well, that brings us to the end of our deep dive into the mysteries of Phobos and Deimos. I hope you enjoyed this journey as much as I did.
It was a pleasure sharing these fascinating moons with you and our listeners.
And to all our listeners out there, thanks for joining us on this cosmic adventure. If you're eager for more space exploration, make sure to follow Cosmos in a Pod on your favorite podcast platform and subscribe to our YouTube channel. We've got a whole universe of stories waiting to be told. Until next time, keep looking up.